Okay, picture this. You've just built a lightning-fast financial trading algorithm, or maybe the most powerful, feature-rich database system on the planet. It does exactly what it's supposed to do, and it's faster than literally anything else out there. But what happens if the people who actually need to use it can't figure it out? Well, the harsh reality, and really the high stakes of software development, is that users judge systems by their interface, not their functionality. Under the hood, your code might be absolute genius, but if the interface is confusing, cluttered, or just plain poorly designed, all that brilliant functionality is practically invisible. And the consequences here, they go way beyond just mild user frustration. A poorly designed interface can actually cause a user to make catastrophic errors. Seriously, think about a medical database or an aviation control system. Bad design in those environments isn't just an annoyance, it's a critical failure. This is exactly why poor user interface design is the #1 reason so many software systems end up completely abandoned. Look, if your interface fails the user, your entire system fails. It's really that simple. Welcome to The Explainer. Today, we are decoding the principles of user interface design, and we're exploring how to bridge that massive gap between complex computer systems and the everyday human beings who actually use them. I'm going to guide you through the structural roadmap of creating interfaces that aren't just usable, but genuinely empowering. Here's our roadmap for The Explainer today. We'll kick things off with why user interfaces matter, then move right into the user-centered approach. After that, we'll break down the 5 styles of interaction, look at presenting information effectively, explore the smart use of color, and finally, we'll wrap the whole thing up with guiding and supporting users.
All right, Section 1, Why User Interfaces Matter.
To really understand why interfaces matter so much today, we just have to look at the massive contrast between modern graphical user interfaces, or GUIs, and those clunky legacy text-based systems of the past. Nowadays, most business systems rely heavily on GUIs for a very simple reason. They are incredibly easy to learn. Users without any prior experience can just jump right in. But honestly, the real magic happens in the workflow. A GUI lets users switch lightning fast from one task to another, interacting with several different apps at once. Because your information stays visible in its own window when you switch your attention, you don't lose your context. Add in fast, full-screen interaction where you can instantly access anywhere on the screen with a mouse, and you've got an incredibly efficient environment.
Moving on to Section 2, the user-centered approach.
This is where we shift our focus to an approach where the needs of the users are absolutely paramount. The crucial point here is that UI design must take the experience and the capabilities of the people using the system into account. We have to remember that humans, well, we have physical and mental limitations. We have limited short-term memory. We get distracted. Think about how easy it is to completely forget what you were doing just because a notification popped up or a coworker asked you a quick question. And most importantly, we naturally make mistakes. Because of these everyday human quirks, UI design absolutely requires the development of prototype interfaces. You simply cannot assume you've nailed human psychology on the very first try. Section 3. The 5 styles of interaction.
So this human-machine dialogue requires a framework for how information flows back and forth. We basically have to solve 2 main problems: how the user gives information to the computer and how the computer gives it back. Let's contrast the 2 extreme ends of the interaction spectrum: direct manipulation versus command languages. Direct manipulation is all about intuitive, fast learning. Users feel like they're in control of the machine and they aren't intimidated by it. On the flip side, we have command languages, like Unix. Experienced power users often prefer these because they're incredibly powerful, flexible, and fast. But the catch, they're terribly hard to learn and offer pretty awful error management for beginners.
Now, when we look at a control panel interface packed with buttons, toggle switches, and menus, we're seeing direct manipulation in action. Because the user is interacting with visual metaphors for tasks and objects, the learning time is super short. But more importantly, users get immediate visual feedback on their actions. If they click a toggle switch and it flips to red, boom, they instantly know the state has changed. And if they make a mistake, they can detect and correct it right then and there without having to retype some complex string of commands. On the other hand, a classic form-based interface is just fantastic for simple data entry. It's ridiculously easy to learn. You just fill in the blanks for things like a new book's title, author, and ISBN. But notice the big drawback here. It consumes a massive amount of screen real estate just to gather a few tiny pieces of data. You're basically trading space for straightforward simplicity.
If we break down the 5 main styles of interaction into a matrix, we see some really clear trade-offs. It's like an ultimate cheat sheet. We have direct manipulation, great for video games and CAD systems, but notoriously hard to implement behind the scenes. Menu selection avoids user error and needs very little typing, which is perfect for general systems, but it's super slow for experienced users who just want to hit a keyboard shortcut. Form fill-in is great for stock control, but as we saw, it takes up a lot of screen space. Command language, powerful and flexible for operating systems, but very hard to learn. And finally, natural language. It's incredibly accessible for things like voice assistants, but the underlying systems that actually have to understand you can still be pretty unreliable.
Section 4. Presenting information effectively. Okay, so when the system talks back to the user, information can be static, meaning it's initialized at the start of a session and never changes, or it can be dynamic, where changes during a session have to be actively communicated. When we're dealing with massive, dynamic data sets, we have to rely on data visualization. This is the essential tool for displaying giant amounts of information in a way that reveals hidden relationships and trends, things a user would literally never spot in a giant flat spreadsheet of raw numbers.
The real-world applications for this are absolutely fascinating. We use data visualization to synthesize weather information from all sorts of sources. We use it to map the entire state of a telephone network as a linked set of nodes. We use it to monitor chemical plants by showing pressures and temperatures across dozens of tanks and pipes. We even use it to display 3D models of molecules or to map out web pages as a giant hyperbolic tree. It essentially transforms raw, overwhelming data into understandable visual context.
But sometimes presenting information effectively is a whole lot simpler. Consider a classic warning dialogue. This is textual highlighting in action. When an exceptional event happens, like a user trying to save a file with a name that already exists, the system needs to interrupt and alert them right away. A simple, bold box with a crystal clear message grounds the user in reality and prevents a potential error from ruining their day.
Section 5. Smart use of color. Color in UI design is not just about making things look pretty. It's an extra dimension used to help the user understand complex information structures and to highlight those exceptional events we just talked about. However, there are 2 massive pitfalls you absolutely need to avoid. First, never use color alone to communicate meaning. If a user is colorblind or viewing on a cheap, low-resolution monitor, that information is entirely lost. Second, avoid the overuse of color in the display. If everything is brightly colored, nothing stands out. Color should aid understanding, not complicate it with a chaotic visual mess. To dodge those pitfalls, there are a few golden rules of color to design by. Don't use too many colors at once. Use color coding to support specific tasks, and whenever possible, allow your users to actually control that coding. And here is a really big one. Always design for monochrome first, and then add color to enhance the experience. Use color consistently across your application. Avoid clashing pairs that literally cause physical eye strain. Use color changes to clearly show status changes, and always account for lower resolution displays.
Section 6. Guiding and supporting users. We established early on that users make mistakes. It's just human nature. So the ultimate test of your interface is what happens when that inevitable mistake occurs. User guidance, which covers online help, error messages, and manuals, cannot be an afterthought. The user guidance system must be seamlessly integrated directly with the user interface itself. When a user needs information or makes an error, the help system should be right there, deeply embedded in the context of what they are trying to achieve. You definitely don't want to force them to go digging through a disconnected 100-page manual.
And this brings our explainer full circle back to our high-stakes hook. Error message design is critically important. A bad error message, one that is confusing, unhelpful, or maybe even condescending, is the ultimate system killer. It can be the exact moment a user throws their hands up and completely rejects your system, regardless of how great the underlying functionality might be. So, I want to leave you with this thought-provoking question to help evaluate your own software systems. If your user makes a mistake today, will your interface help them recover smoothly, or will it drive them away forever? Great user interface design isn't just about pixels on a screen. It's about anticipating human behavior and building a system that truly supports the person sitting on the other side of the keyboard. Thanks for joining me on The Explainer, and keep building with the user in mind.